All right, so we're diving into the integumentary system. You have your skeletal system. We already did integumentary, so let's not worry about that. Into your skeletal system. You have the study guide, right? I'll pop it up here again just to make sure you know where we're going. It looks like this is not wanting to give me that on this. But you know where it is, right? You all got it. So you'll have to keep me on track. So let's talk about these quick functions of the integumentary, the skeletal system. And again, we'll come back to these because there's much more detail coming. But quick hits, what does the skeletal system do? What's its function? Give me one, quick. Yes, ma'am. Structure. It gives us actual form, so we're not just a blob of skin on the ground. Sir? A place to attach muscles, right? And we'll talk more about how that works. But every muscle attaches to, has an origin and an insertion. And when they contract, it pulls those together, which makes you move. Aaron? Support. Okay, actually keeping things in place so your organs inside don't just plop out between your legs. This would be a problem. Yes? Produces the red blood cells. And again, our lab we did on the sickle cell anemia piece, that's when that process doesn't work well, right? What else? Attachment for muscles gives those support pieces, absolutely. Anything else we missed there? Oh, one more. Production and storage of minerals, right? The things like calcium that we know makes our bones strong, we also need those for our nerves to work, for our muscles to work. And their bones are where those things are stored for later use. All right, so let's talk about the pieces of this bone. And we're really focusing very much on long bones. You learned a little bit about sesamoid bones. Those are like your patella is a sesamoid bone, right? That's ensheathed in a tendon. Don't make fun of me, Cameron. All right. So here we go. And this is a diagram, right? You'll see this on your assessment. I do want to make sure you know that I do want you to know that diagram that is there on page 145. Okay? You can break these long bones up. By the way, what bone is this? Femur, definitely. You can tell by that nice little head going off with the nice big condyles on the bottom. Anybody know, is this the posterior or the anterior side of the femur? Ooh, now I'm testing you. 50-50 chance. Posterior. Good job. Posterior. And you know that because it has these nice round areas on this side, right? So that way your knee can bend like this, right? On the front side, there's a nice little dip, a little groove where your patella sits in it, okay? So we break these long bones into two pieces. The epiphyses, or the epiphysis is singular, and the diaphysis is in the middle, right? The epiphysis are the two ends. A diaphysis is in the middle. The edges are made of, thank you, the edges are made of this compact bone. We'll talk about the microscopic structure in a second. The edges are the compact bone. The inside is the spongy bone. And it really is just what it sounds like, right? Compact means it's thick, it's hard. It takes all the weight, gives you all the strength. Spongy means it's open, lots of areas. Mr. Rowe needs you, Josh. We're cool there? Okay. You can see that there are these little lines at the top because they've kind of given you an inside look at the neck up on the very top of the bone there. That those are called epiphyseal plates. Does anybody know what those do? You've heard of them before, I'm sure. If I gave you a different name for it, if I called them the growth plates, do you know that? Oh, maybe not. Wow. So this is where actually the growth of the bone is taking place, is on these epiphyseal plates. When we'll look at how the bone forms, you'll see it kind of forms on both ends and kind of pushes stuff to the middle. And these plates are where that evidence that these bones are growing still. So when you go to the doctor, let's say you're a teenager, a young teenager, and they take an x-ray of you, and they'll say, oh boy, yeah, that Owen, he's not done growing yet. How do they know that? Because those epiphyseal plates are still open. They can still tell that bone is being produced, and it's going to keep growing. We had when my son, he fractured his collarbone, probably 3 or 4 years ago, and they took an x-ray, and he was already pretty tall, and they're like, oh no, he's got lots of growing still to do. Again, because that collarbone was still, we could see those epiphyseal plates in there, and the collarbone in the humerus. We haven't had an x-ray recently. I'm not sure how much more he has, but I grew even more when I got into college, so we'll see. Tall boy. His goal in life was to be taller than I am, and he's officially done that, so it's all downhill from here, I guess, for him. Yeah. All right. But I can still take him down, so it's all right. We're good. You see on the outside here that there's this articular cartilage. And what this is a layer that just protects the part of the bone that's getting the forces. So let me grab my femur and the hip. So here's the hip, here's the femur. Right? So these guys are, actually this is the wrong side, but we'll just pretend it's okay. Like this, right? This socket, this is the head of the femur, goes in here, right? Is that the opposite one? Nope, same one. I'll just take one, that's all right. That's all right, it works. Thank you. But can you see that there's this nice smooth area? That's where that articular cartilage covers that. So it's just a protective area, because this is doing this all the time, right? Up, down, in and out. Right? And we want that to be nice and protected. Has anybody ever damaged cartilage in their knee, maybe? That's a very common place for that to happen. No, amazingly, those are two of the same sides. Wow. We're just striking out both ways. I appreciate it. Okay? So you'll have it there. Where else on this femur would you have articular cartilage? On the end, exactly. These are called the condyles. You saw some of those terms for different pieces yesterday, right? The condyles. And this would be where it rubs on your tibia as you straighten and bend your knee. We cool? Okay. Inside that spongy bone, in the diaphysis, you have the bone marrow, right? You have the red marrow, which produces what? Blood cells. Red blood cells, exactly. And then you have the yellow marrow, which is interesting. One of them has to be. There we go. Well done, Mrs. Serrano. So there you go. That's actually anatomically correct now. The anterior side, posterior side. So what happens in the yellow marrow? Marrow, not marrow. Yellow marrow, anyone? Sorry? It does. It's one of these store fat areas. We don't do tons of it there. We tend to store fat other places. But that is something you can do there in that yellow marrow. This periosteum is a little coating, a little layer of tissue that goes around the bone itself. Your body is very much like a package from Amazon. You know, like you order this little tiny little something, and it comes, that something is in a something, and that something is in a package, and that package is wrapped in plastic, and that plastic is wrapped in, you with me? Your body's very much the same. And you like open, and it's like this little tiny thing. Yeah, it drives me crazy. Because why? It's protecting, right? It's helping keeping things together. So that's that periosteum, is that outer layer. This inside little hole in the middle, even though it's actually filled with marrow, we call that the medullary cavity. The middle, it's a cavity. It's an open area on the inside of the bone. So the cavity is the space in the bone where the marrow actually exists. Like there's not really actually open space there too much. It's filled with other things. But that space in the middle of the bone is what they call the medullary cavity. Right. So I'm saying the marrow fills the medullary cavity. Yep. The spaces containing it are up here in the neck. This is called the head of the femur. This is the neck of the femur. So it's up in that area there. It is. Yeah, yeah. It does have a much yellowish, because fat has got that yellowish tint to it. And you'll see that when we do our cats. Some of our cats will be a little fatter than others. And you'll see. Yeah, you'll see. I just, from the outside of my neighborhood, I just grab them and, no, we order them from a company. Yeah. Here's a picture so you can see, and this is a nice picture that's in your textbook, I think, as well, right? That right there on page 145, showing you the difference between that compact bone and spongy bone, right? Spongy in the middle, right? Compact on the edges. We cool? All right, let's keep rolling. The microscopic structure. So this is here on page 145 and 146. Remember that I had asked you to know some terminology from that one, right? So the compact bone, right? We'll start with compact bone. Remember, compact and spongy, two different types of the bone pieces. The compact bone has little osteocytes. Those are the actual bone cells. And those osteocytes are in these small little chambers, little bony chambers. What do we call those little chambers? The lacunae. Yep, they're like little moon areas. That's what lacuna is, like a moon, like an area like that. Okay? So those little lacunae are arranged in a cylindrical arrangement like this. And what do we call those cylinders? Those are osteons. And can you see that we put a bunch of those together to make that compact bone? Like here's a little circle rod thing. Here's a little circle, these little osteons together. I'll get your question 1 second. Has anybody seen how they build skyscrapers? Like this is what they do. They take these bundles of rods of steel and they put them together and then put those bundles together and then more bundles together, and that's what gives you the framework for the building. Why? Because it's super strong. Like for its weight, it's super strong. Are you with me? Question. They would be much smaller than this. You can't really see it in these diagrams. It's just like each individual of those cells are in the little lacunae. I don't think there's a picture they give you. Oh, there you go, yeah. If you zoom in, the zoomed in, yeah. But so it would be this guy right here, the little space. So that actual little blue guy, that's the osteocyte that's making the bone. Yes. No. It's just that small bony chamber. That is what that osteocyte is contained in. Okay, so we put those osteons together, right? And that's what makes this compact bone. In the center of those osteons is something called the central canal. What's in that central canal? If you just look, blood vessels. That's the red and the blue ones. What about the yellow ones? Nerves. You got it. So this is basically, because basically you've got these bundles, like, and I always think they look like tree trunks. You know what I mean? If you take a tree trunk and cut it, that's what it looks like, I think. You've got like basically all these little tree trunks there. You need ways for blood and nerves to get into the bone. That's what those central canals are for. Are we cool? Those central canals are connected by these little things called perforating canals, meaning they're actually going through these osteons to connect different central canals together. The medullary cavity would be so that would be this space in the middle of the long bone, the whole huge thing. Remember, we're zoomed way in here. We're looking at the microscopic structure. So on a macroscopic level, you're correct. The big space in the middle is called the medullary cavity. Yep. You with me, friends? And if you zoom in even further, there's these little tiny little canals called canaliculus, right? It's Latin for like really tiny canal. Okay? So that's our compact bone. Our spongy bone, which they don't really show you too well, instead of them being in these osteons, the spongy bone, the cells lie in these things called trabecules. Trabecules. And they get their nutrients just from diffusion, just from the other blood cells that are here, right, that run down that middle. They'll get the blood from that. It would be kind of these areas here in the spongy bone. They don't really show it very well. They're very much more focused on the compact bone. Yes. Mm-hmm. Mm-hmm. An osteon is this actual, like a tree trunk, the circular structure. Questions there? So you very well may see a little question on your assessment about that piece, just explaining the microscopic structure. Maybe it'd be a multiple choice, maybe it'd be a fill in the blank, showing, hey, this is how things are put together. Are we cool? And again, the reason why is strength. We want strong bones that aren't like super duper heavy, right? That's the big flaw in Wolverine's character. If his bones were actually made of adamantium, he'd be too heavy. He couldn't move. That's good. All right. Yes, ma'am. What I would encourage you to do, there's about 2 paragraphs that are there on page 145 and 146. I would go through those guys. Because what they do is they show you the words and they tell you how things are arranged. So if you can tell me in your own words, using those 4 or 5 vocab words that I put on that study guide, you'll be solid. Okay, let's dive. We've got 10 minutes here. We're doing good. Let's dive into how the bones develop and grow. Yes, sir. The perforating canal is connecting the central channels of different osteons. Right? So here's central canal. They've given you a cutout view here. Here's the central canals of 2 separate osteons. A perforating canal goes between those 2. The trabeculae. Those are the spaces in the spongy bone. Yeah. Again, if you go, again, your textbook does a very good job of explaining that on page 145 and 146. That's where I would push you toward for more detail. Okay. So what's amazing is a baby's bones really aren't bone. What? Not true. They're mostly connective tissue. They're mostly this cartilaginous connective tissue. They're not super hard, right? And those bones, over the course of the development of the baby, change from cartilage to bone tissue. They go from connective tissue to bone tissue. The thing that lays down bone is called osteoblasts. Osteoblasts blast out osteons, blast out bone cells. Remember another blast we talked about? Fibroblast, which blast out fibers, right? Blast out connective tissue fibers. Again, I told you, anatomists are not very creative. We just tell you what it does, except we just do it in Latin. Okay? Good. So how do they do that? Let's talk a bit more about that. Yeah, this is all here. Let's just go right to this diagram. Where's this at in your textbook? This is here on, thank you, 147. That you start off with this bone, and we're talking about these long bones, of course, about these endochondrial bones, because there are the intramembranous bones. That's like the bones of the skull. And those guys just basically fuse together. That's the key of that piece of that. For these endochondrial bones, they start off as cartilage, and can you see that they start calcifying in the middle? That's where the periosteum begins, right? And then it starts pushing that toward the outside. As the inside is hardening, it's pushing it to the outside. Because remember, the periosteum is that layer that goes around the bones, right? Like the Amazon wrap that holds it in place. And you can see that we start getting these two areas of ossification, becoming bone, right? That's what ossification means. Up in the top of the bone and up down at the bottom of the bone. What do we call those two areas, the top and the bottom of the bone? The epiphyses, right? Or epiphysis is singular. So that's where we start seeing this bone forming, right? Our primary ossification is happening in the center, but you have it sent out also to these secondary sites up in the epiphyses. And eventually, those epiphyses are really what's doing all the growing, all the connecting, all the ossifying. Your bones lengthen, right? Thankfully, you aren't as small as you were when you were born, right? You've certainly grown, and that's just how to do it. The bones are just from the center growing out, from the ends growing out to give you more size as you grow. If you x-rayed my bones, you would still see little lines where those epiphyseal plates were, but for me, they're no longer open, as I am no longer growing up, just out. Okay? It's life. It's life. Are you with me, my friends? If I'm not mistaken, on your study guide, I asked you just to be able, as a short answer, to be able to explain that process. And again, the key pieces are you are ossifying in the middle as well as in the two epiphyses, right? Taking the cartilage and turning it into bone. That's our goal. So that therefore you go from really soft, bendy bones as a little baby to nice, strong, sturdy bones as a teenager adult. It's actually pushing those harder bones. Just like in your skin, like the bottom layers are where dividing, and as they divide, it kind of pushes them up so it can divide more. It's the same kind of process, except it's just tilted on its side, so it's pushing them outward. Mm-hmm. Yep. Good, good, good. We also have these cells that are called osteoclasts. So remember, osteoblasts were doing what? Blasting osteons, blasting actual, and if you put that on a test, I want you to explain more, okay? Blasting osteons would not be a correct answer. Give me more. They create, they make, they produce these bone cells. An osteoclast is exactly the opposite. An osteoclast will break down the bone. You say, well, wait, why do we need to break down the bone? Because remember, we use the calcium to do other things, right? For our muscles to fire, for our nerves to fire, for different hormones to be created, we need these minerals. So your body's in this constant state of tearing down bone, making bone back, tearing it down, making it back, tearing it down, making it back. For someone like you, that process is very normal. But what if you start tearing down the bone too fast and you're not able to replace it as quickly? What would we call that disease? Osteoporosis, where my bones get thinned out. They're not as thick because those osteoclasts are breaking it down faster than the osteoblasts can put it back together. Sure, it's doing some repairing, certainly, but it's just we need the calcium in there to actually live. And this is our primary storage place for it. And again, there's a nice little paragraph on page 148 that talks about the homeostasis of bone tissue. That's exactly what we're talking about here. What was that? Oh, yeah, sure. Yeah, we'll show this if you don't mind. Can you see this here? I know you can't see it on the recording now that I'm showing it, but that you can see here's our normal bone matrix, and they're zoomed way in on the compact bone. I'll move this around. I promise I'll be careful with your computer. Okay? And so there's normal, and there's osteoporosis. So instead of it being this nice, thick, compact bone, it's much thinner. It almost looks like spongy bone, doesn't it? Yeah. So again, the point is that that'll be much less strong, much less terrible English, It's significantly weaker. I mean, so who does this affect mostly? Older folks certainly, even more specific. Who? Ladies certainly more than men. And if you had to break it down even more, you would say white ladies even more than African American or Asian. So like, it's just genetics seems to be the case. I don't know the actual why behind that, but that's certainly what we've seen. Sure. How do you help prevent that? Okay, you make sure you're getting enough calcium. We can have a conversation about that. There are things in it, but the calcium is good. Yeah. Yes. It's called good advertising. There's lots of other hormones and pieces. I'm not sure that I would say it's a terrible thing for you, but there's trade-offs, man. And almost anything has trade-offs. Yeah. What else can you do? And again, imagine this little old lady, right? This is how I think about it. What is she not doing very much of? Exercising, walking. Because how bones work, when I'm walking, when I'm actually compacting that bone, right? I'm causing stress. So that makes the osteoblast put down more bone. If I'm just sitting on the couch knitting, if I'm an old lady, because I guess that's what old ladies do. Don't tell my wife I said that because she knits. You're not getting that exercise, right? You're not getting that impact on the bones. Good, good, good. All right, I'm going to stop there because we're going to run out of time. I did put up on Schoology, don't leave yet. I don't have it pulled up, so I won't pull it up on the computer. But I did put up that Monday is when I'm asking you to have your questions finished by. Okay? Again, that's been up there for a number of days. I haven't mentioned it, but it has been there for you. Okay? The point of that is to help you read, right? Read, do question. Read, do questions. Don't do all 1 to 35 in one point. Okay? Go and sin no more.
William never came in, right?
Did not, no.
Okay.